Hello दोस्तों, what we'll be doing today is conductometric titration. Conductometric titration. Now, this is one of the most important topic and a crucial topic which is asked in JEE, as mains as well as advanced. And each year JEE asks question from this. So last year also it asked a question from this particular topic. In the end of our video lecture, we will look at the question. You can see this question has been taken from JEE 2000 Advanced 2024. We'll be able to solve this question at the end of the video. But before that, what we should do is we should understand the basic concepts and that are needed to solve this question. So the question asked in this particular topic is really very easy and is actually a question of graph. So if you understand the basic concepts, so you can easily apply them and try to get the answer in a very easy way. These are easy marks which are provided. The only catch is that you should understand the particular concept in detail. Now, as the name suggests, conductometric titration. So what we'll be doing is we'll be doing titration. That means a reaction of a acid or base, or a redox reaction, and we'll be measuring its potential or conductivity of the solution in order to understand what is the behavior of the solution and when is the acid base uh, titration is completed or the particular redox reaction is completed out. And then we'll plot the graph and we'll find out the equivalence point. Equivalence point is the point at which equivalence point is the point at which the reaction of acid base is completed or the particular redox reaction is completed. So let's start with the concept. So what we should first understand is, if I talk about the conductivity of ions, so among cation, the conductivity of H plus ion is really high, and among anion the conductivity of OH minus ion is really high. The reason behind the high conductivity of H plus ion and OH minus ion is proton jump. So proton jump mechanism. So we can explain this high conductivity of H plus ion and OH minus ion with the help of proton jump mechanism. Now what is this mechanism? Let's have a slight idea about this. So what happened when we, in particular, what happened in case of H plus ion is, let's suppose this is the positive terminal and this is the negative terminal or negative electrode. So H plus ion is present over here and H2O is present in the solution, like this. Now one of the way of the ion to move from over here to the from one of the electrode to other electrode is by moving all the way through, and in this movement of the ion will have a collision with other molecule, other ions, in turn which will reduce its energy as well as speed. But what happens with H plus ion is, now this water molecule which is adjacent to this H plus ion has a lone pair, and so instantaneously this H plus ion will be captured by this lone pair of oxygen, and it will convert itself into HOH, and it will break the bond with this hydrogen. Now again the adjacent water molecule will do the same because it also has lone pair, so it will break the bond. And H, what will happen? H plus ion, without moving this, it reaches the other end or towards the other electrode. So we have seen, because of this, and this particular thing is called proton jump. The H2O molecule adjacent to this H plus ion will capture this H plus ion, release one of the hydrogen. The released hydrogen will be captured by next water molecules in a similar way. It will again release the H plus ion, and in turn this H plus ion will move from one electrode towards another electrode. The same thing happens with OH minus ion also. So if we see what happens over here is, let's say this is a negative electrode and there is OH minus ion and water molecule adjacent to it. So this time this OH minus will capture this H plus ion and capture this OH minus ion, and it will form water molecule, releasing out, and this H2O molecule will release out one OH minus ion, and subsequently the other adjacent H2O molecule will again capture this this OH minus will capture H plus from the other subsequent H2O, and the OH ion will be produced by this particular water molecule. So as a result, you can see that the OH ion, which earlier was toward the negative ion, is now moved towards the positive ion because of this proton jump. So this is the reason why H plus and OH minus have exceptionally high conductivity. And now if I talk about in general about the conductivity of ions, so conductivity depends on two factors. First is mobility of ion, and this we have seen that the mobility of H plus and OH minus is exceptionally high. Second is the concentration of ion. So now we have gathered all the information that is required to understand this conductometric titration. So we can start by discussing out the individual cases. So let's discuss the cases one by one. And one more thing before that, you should understand that there are few assumptions that we take while doing this conductometric titration. First assumption is the conductivity of H2O is 0, and apart from it you must also remember that if I talk in general about the conductivity, so conductivity of strong acid or strong base is much higher than the conductivity of salt, which will be higher than conductivity of weak acid or weak base. So these are the things that you should keep in mind. So now let's discuss our first case, that is titration of strong acid with strong base. And we will take an example in which we'll take HCl in the beaker and we will pour in NaOH. So what will happen now? Suppose HCl was there and we are pouring in NaOH. So as NaOH will come into contact with HCl, it will form NaCl plus H2O. Now let's assume that NaCl was 5 mole. We are just doing this to understand the concept behind, and then we can plot the graph and understand it. So for the understanding, I am supposing that HCl is 5 mole and NaOH we have poured in 1 mole. So NaCl will also be formed 1 mole. So at the end, what will happen? We will have 4 mole of HCl left and 1 mole of NaCl. So now I can certainly say that in the solution there will be 4 mole of H plus ion, 1 mole of 1 mole of Na plus ion, and see Cl ion and Cl ion over here are common. So 5 mole of Cl minus ion. So there will be no change in concentration of Cl minus ion. That means conductivity will not be affected because there is no change in case of Cl minus ion. But if I see over here, the H plus ion has decreased from 5 mole to 4 mole, and in place of 1 mole of H plus ion, 1 mole of Na plus ion came in the solution. Now as I certainly know that conductivity of H plus is greater than conductivity of Na plus. Now if I remove 1 mole of H plus ion and introduce 1 mole of Na plus ion, certainly there will be decrease in the conductivity of the solution. So how the graph will look like if I plot this graph with molar conductivity versus volume of NaOH. So certainly the conductivity will start to decrease. It will decrease till all the HCl in the solution has been converted out to NaCl by the incoming NaOH. Then what will happen after all the HCl are used up? The again if we add NaOH, so in the solution NaOH and NaCl will be there. Now as I know, because of this OH minus ion, increased concentration of OH minus ion and increased concentration of Na plus ion, the conductivity of the solution will start to increase. So the graph will look like this, and this is the point. This is known as equivalence point. Equivalence point. Here is the it is the point where the titrant or one of the reactant of that is HCl, which we are measuring, has ended up, and now all the incoming NaOH has utilized all the H plus ion HCl ion in the solution. Now let's discuss about the second case, titration of strong acid with weak base. So now let's discuss about titration of strong acid with weak base. So what we'll be doing over here is we'll take strong acid, let's say HCl, and we'll add weak base, let's say NH4OH. So how the reaction will proceed? HCl, which is in the solution, will react with incoming NH4OH and get converted into NH4Cl plus H2O. Now again, if I assume, just to understand that this was 5 mole and we have introduced 1 mole of NH4OH, so 1 mole of NH4Cl will form. So at the end of the first step, what I'll have in my solution is 4 mole of HCl and 1 mole of NH4Cl. Now again, if I look at the concentration of Cl minus ion is after this reaction, the concentration of Cl minus ion is exactly same as before, that is 5 mole. But I can see that 1 mole of H plus ion has been replaced by 1 mole of NH4 ion. That means the conductivity of the solution should decrease. So the graph should look like decreasing as in the earlier case. It will decrease till it reaches its equivalence point. This is the equivalence point. What will happen after the equivalence point? All the HCl would have been converted to NH4Cl. So now in the solution we have NH4Cl and we are introducing NH4OH. Now you see NH4OH is a weak base, and due to common ion effect and because of common ion effect of NH4Cl, the NH4OH won't break down into its ion. That means this reaction NH4OH converting to NH4 plus of OH minus, this won't happen, or it will be pushed down in the backward direction because of presence of NH4 ion in the solution that was from NH4Cl. So because of this common ion effect, the OH ion won't be present in the solution, so the conductivity of the solution won't increase, and in turn the conductivity will become constant. So because of this common ion effect, the conductivity of the solution has become constant. Now let's discuss the third case, titration of weak acid with a strong base. Now let's take one example. We have taken over here CH3COOH and introduced NaOH in the solution. So initially we had CH3COOH plus NaOH. So this will form CH3COONA plus H2O. Now what will happen over here in the solution is, since this is a weak acid, this will produce a very small amount of H plus ion, and as soon as we introduced NaOH in that, so this H plus ion will instantaneously react with this NaOH. So there will be a slight decrease in the conductivity of the solution, but now we know that as soon as it reacts with NaOH, it will start to produce CH3CONA, and we have seen earlier also that conductivity of salt is greater than conductivity of weak acid, so the conductivity starts to increase. The conductivity starts to increase. Now as we keep on pouring in the NaOH, the CH3CONA will keep on forming, CH3COH will be used up. At the end, when the equivalence point will hit, all the CH3COH will be converted to CH3CONA, and now if I put in more NaOH, so because of this high conductivity of OH minus ion, the conductivity of the solution will increase drastically. Now sometime over here this part of graph is not shown in the question. You may get a question in which this part of graph is not shown. So but the basic concepts remains the same. As this CH3COH is weak acid, the H plus ion concentration will be very low, so we can skip this particular part. But in reality, when you do the experiment in the lab, you will get this part. So now this part is because there will be certainly, since although it's a weak acid CH3COH, but there will certainly be certain amount of H plus ion in the solution, and since we are using up that H plus ion, the conductivity of the solution should decrease. But as this H plus ion is used, a salt is formed and the conductivity of salt is more than the conductivity of weak acid. So conductivity of the solution will start to increase. It will increase till its equivalent point with a lesser slope, and then the slope of the graph will drastically increase because now what we are introducing in the solution is OH minus ion, and the conductivity will certainly increase. So this was the basic graphs that are present. Now let's come back and solve this question number 14 of JEE Advanced 2024. Now what is given in the question is, in a conductometric titration, a small volume, we must see that a small volume of titrant of higher concentration is added stepwise. So titrant is being added in the titrate stepwise, and the titrate stepwise, and larger volume of titrate of much lower concentration. So the titrate is large volume and its concentration is lower. So if the concentration is lower, I can apply the Coriolis law of independent migration of ions on this titrate, and the conductance is measured after each addition. The limiting ionic conductivity value for different ions in aqueous solution is given below. So this value of lambda naught can be applied only when the concentration is low. So we can apply it only on titrate and not on titrant, since its concentration is not very low. Now for different combination of titrates and titrants, list 1 and list 2 are given. Match the entry of list 1 with appropriate entry of list 2 and choose the correct option. Now let's start with the first one. Now I know that this is a large volume and this is low volume. So when KCl will react with AgNO3, it will produce KNO3 plus AgCl, which will be precipitate. So I'm not at all interested in the precipitate. Now if I look at this particular equation, this is in large volume, so KNO3 will also be produced in large volume. Now KCl, if I look at the conductivity of KCl, so lambda naught of KCl will be equal to 7.4 plus 7.6. Cl minus is 7.6 and K plus is 7.4. So this will become 15, and lambda naught for KNO3 will be equal to, so K is 7.4 and NO3 is 7.2. So this will be 14.6. So as I can see that the lambda naught value or conductance is decreasing, but the decrease is very slow. So now which options it is decreasing? In option number 2, option number 3 and option number 5. Now what will happen after KNO3? It will not become constant. So why it is not becoming constant? Because when we'll introduce more AgNO3, so again we are introducing Ag ion, NO3 minus ion, and KNO3 also has NO3 minus ion. So we will increase the concentration of NO3 minus ion in the solution. So this conductance will not become constant. So I cannot say that fifth one is will be the answer. Certainly one of the answer would either be second one or third one. But I can also see that the decrease over here is very slow. So the most probable answer would be 3. And if I look at the option, C option should be correct. Now let's check other part of the options also. So now if I talk about AgNO3 and KCl. So AgNO3 will be in the solution which is of large volume. KCl we are producing KNO3. Now lambda naught value for AgNO3, for Ag it is 6.2 and NO3 it is 7.2. So 6.2, 7.2, 13.4. 6.2 and 7.2 is 13.4. And for KNO3 we have calculated just now that lambda naught is 14.6. So certainly there will be increase in the conductivity. Now in which option it is increasing? Now after increase, you see, first it will increase. So certainly there is only one option in which it is increasing, so fourth. So Q will be 4. P can be either 2 or 3. But my greater emphasis was on 3. Now let's check R. So NaOH plus HCl, it will form NaCl plus H2O. So NaOH is in large volume and NaCl will also be in large volume. The conductivity of or lambda naught for NaOH will be equal to Na it is 5 and OH it is 19.9, so 24.9. And for NaCl it will be Na5 and Cl minus is 7.6, so 12.6. So certainly it is decreasing, and it is decreasing very drastically. So for R it is decreasing. So first part of R is should decrease. So it can either be 2, 3 or 5. Now let's check what is happening after we have introduced or we have neutralized all the NaOH. So if we add more HCl in the solution, what will happen? It will produce more Cl minus ion and H plus ion also. So drastically it will start to increase. So it is increasing drastically in second option. So R can be second or third. Let's check S. NaOH and CH3COH. So NaOH being mixed with CH3COOH. Now NaOH is in large volume, so CH3COONA will also be in large volume. Now let's calculate lambda naught for NaOH. So lambda naught for NaOH will be Na plus OH 24.9 and CH3OONA. So CH3CO minus is 4.1 and Na is 5. So this will be 9.1. Now over here the decrease is large, and after this titration becomes over, after equivalence point, what is happening is when we will add more CH3COH, so the conductivity of solution won't increase, because all by default or from earlier reaction also this particular solution has CH3CO minus ion, and it won't let CH3COH dissociate because of common ion effect. So the conductance of the solution will become constant. So certainly S will be 5. Now let's see which option is there. So P can be 2 or 3. So P can be 2 or 3, B and C, and S will be 5. So option number C is the correct answer. So that